So why do we need statistics anyway? Well, if everyone in the world was the same height, had the same color of hair, weighed the same, we wouldn't need statistics. If everyone in the world made the same amount of money, had the same job, we wouldn't need statistics. If every student who went to college majored in the same thing, bought exactly the same textbooks for exactly the same price, we wouldn't need statistics. If every baby that was born had exactly the same color hair, the same weight, the same height, length, we wouldn't need statistics. But obviously that is not true. Statistics is a way, it is simply a tool for us to deal with the world of variability and to be able to try to quantify, to put a number with all of the variability that takes place. So, let's look at what we already know about statistics from a long time ago. We're familiar with measures of center, mean, median, mode. Now, I'm going to be honest, mode doesn't come up a whole lot in statistics from my experience. Mean and median do, in particular, mean. The mean is what it's always been, just the arithmetic mean. Just you add up all of your values, you divide by how many values you have, it's the mean. Nothing harder than that. The median is still, you put them in order from small to big, pick the middle, or if it's even, you pick the average of the two, middle. No big deal. When we look at how much things vary, the basic ideas are range, which is a really easy way to deal with something, and that is just simply the high value minus the low value. Well, it tells us something. If I'm looking at the range of heights in my first period statistics class, and I look at the least height to the highest height, there is a pretty wide range. There's probably somewhere in the neighborhood of 1.5 feet. That's a lot. These are high school students. However, I can narrow that down. I can give a little better information about it with something called a standard deviation. Now, what's a deviation? Well, it's how far things deviate from something. And in this case, we're going to talk about how far they deviate from the mean. So what the standard deviation is, and I'll talk about its actual formula in another video, but what it basically is if I take if I take the average of all the heights in my class, and I find out what it is, and let's say it's 5'8", and I take Andrew's height, and I subtract it from, I forget the difference between his height and the average, then perhaps it's 2 inches. If I get the difference, the deviation from the mean of Ashley's height, it might be 8 inches. If I get Hayden's deviation, it also might be 8 inches. But it would be headed in a different direction. Just because the deviation is 8 doesn't mean that it was always 8 under. It could be 8 under, it could be 8 over. But what happens is we do this. We look at the amount that each person's height differs from the average. If they're 5'8", their deviation is 0. If they're 5'9", it's 1. If they're 5'7", it's 1. Obviously, we can assign signs as well. But if I am looking for the average amount that a person in this class differs from the average, that is typically a pretty easy definition for standard deviation. It's the deviations, but it's the standard one. Okay. There is a formula. There are a couple of formulas to deal with that. But that's the bottom line of what it means. Now, the reason we deal with mean, median, standard deviations, ranges, is typically because we're trying to compare one group to another, and it's used as a comparative tool. Okay, let's think about what else we want to talk about. Statistics is a huge, huge field. It's its own field. Applications in just almost anything we could think about in business. Walmart doesn't just willy-nilly decide how many jars of olives and pickles they're going to order. They are looking back at past data to see what's sold. Attorneys are not going to take a suit for which data has shown folks don't win, they don't win, they don't win. They're looking back at past data. Let's see what else. Engineers. It would be helpful to know if a bridge is being built in a windy area, how much wind their particular design can withstand and still be safe. There is a famous example of a bridge that didn't meet those qualifications and failed. Sports analysts are looking at past records versus current records. There are fields, every field now collects data. Data is increasing at an incredible rate daily. What statistics does is it gives us a way to try to manage that data quantitatively, get a handle on it. Raw data, just the data out by itself, is really overwhelming, doesn't tell us anything. Statistics gives us a way to narrow it down, quantify it, give it a number, say this is the average, and on average, this is how much the values vary from that particular average. There are so many facets of statistics and probability, and I will cover those in future videos.